This graph shows the cardiac cycle. We've color-coded the left atrium in white, the left ventricle in red, and the aorta in green. When we talk about heart function, especially pressures, we focus on three key chambers: the atrium, ventricle, and aorta. While the left and right sides of the heart are similar, their pressures are different. Here we are focusing on the left heart. The first event of the cycle is atrial systole or atrial contraction. When the atrium contracts, the pressure inside it increases. This is called the A wave at this point. The mitral valve is open and the pressure from the atrium transfers to the ventricle, causing a rise in ventricular pressure. Before atrial contraction, ventricular pressure is almost zero. As the atrium contracts, ventricular pressure increases slightly to just over 5 mm of mercury. At this time, the aortic valve is still closed, so the pressure in the aorta remains at about 80 mm of mercury, independent of the ventricle. At this step, the mitral valve is open and the aortic valve is closed. The pressure in the ventricle doesn't affect the aorta yet. Once the atrium finishes contracting and has pushed all its blood into the ventricle, ventricular contraction begins. As the ventricle starts to contract, the mitral valve closes, which results in the C wave forming in the atrium due to the upward bulging of the mitral valve into the atrium. The C wave reflects the brief increase in atrial pressure caused by the initial ventricular contraction against the closed mitral valve. When the ventricle starts contracting, its pressure rises to around 5 mm of mercury. Once the pressure exceeds that, the mitral valve closes, which generates the S1 sound. The aortic valve is still closed at this point. The first phase of ventricular contraction is isovolumetric contraction, where volume stays at same because both the mitral and aortic valve are closed. As the ventricular pressure increases, it eventually matches aortic pressure at around 80 mm of mercury. Once the ventricular pressure exceeds 80 mm of mercury, the aortic valve opens, but this opening doesn't create any sound in a healthy heart. With the aortic valve open, blood is rapidly ejected into the aorta. This is the rapid ejection phase. And in a healthy person, the aortic pressure rises to around 120 mm of mercury by the end of this phase. As the ventricle starts to relax, aortic pressure stays high due to the elasticity of the aorta. Eventually, the ventricle pressure drops below the aortic pressure, causing the aortic valve to close, which creates this S2 sound. Now let's talk briefly about the atrium. After the mitral valve closes, the atrium acts as a reservoir, and the pressure inside gradually rises, forming the V wave. During the slow ejection phase, the rates of blood ejection from the ventricle slows down, the mitral valve remains closed, and the aortic valve stays open. But the ventricular pressure continues to drop. At the end of the slow ejection phase, the aortic valve closes once the pressure in the aorta exceeds the ventricular pressure. After S2, the relaxation phase begins. The mitral valve remains closed and the atrium is still functioning as a reservoir, with the V wave continuing to rise. This marks the start of the diastole, beginning with isovolumetric relaxation, where all valves are closed and the ventricular pressure keeps dropping. The closure of the aortic valve briefly increases aortic pressure, but the connection between the ventricle and aorta is broken. When the ventricular pressure falls below the atrial pressure, the mitral valve opens, starting the rapid passive ventricular filling phase. During this phase, the Y wave forms as atrial pressure decreases. The mitral valve remains open during rapid filling. At the end of the rapid filling phase, we might hear S3, which can be normal in young people or during physical activity, but it can also indicate pathology. S3 is caused by a large amount of blood hitting a compliant left ventricle, often related to conditions like ischemic heart disease or cardiomyopathy. Next is the slow passive ventricular filling phase. During this phase, blood flows from the pulmonary veins directly into the ventricle, and the atrium acts as a pass-through, with its pressure remaining steady. The final step in ventricular filling is atrial contraction, which pushes the remaining 20% of blood into the ventricle. S4, which is always pathological, occurs when the atrium contracts against a stiff ventricle. Remember, 80% of ventricular filling happens passively, while 20% of filling comes from atrial contraction. That extra 20% becomes crucial during exercise. In terms of timing, atrial systole is a small part of the cardiac cycle. With a heart rate of 72 beats per minute, each cycle lasts about 0.8 seconds. Atrial systole takes only 0.1 seconds, while the remaining 0.17 seconds are diastole. For the ventricle, systole takes about 0.3 seconds and diastole takes about 0.5 seconds. Now let's move to the ventricle volume diagram. During atrial contraction, there is a small increase in volume. During isovolumetric contraction, the volume stays at the same. During the rapid and slow ejection phases, the volume decreases. In isovolumetric relaxation, the volume doesn't change again. Then during rapid filling, the volume increases, followed by slow filling and atrial contraction, and the cycle repeats. Finally, let's tie this all together with the ECG. The P wave comes just before the atrial A wave. Then we have the QRS complex, followed by the C segment, and finally the T wave.